Hi, everyone. Hi, people. How are you? Patricia Trejo. You can call me Patty. I'm actually engineering director and head of software development at Carnage by Uber. And today I'm going to talk about delivery flow metrics in software development. So, first of all, what the heck are flow metrics? And in this case, we talk that flow metrics are tools to constantly measure the flow of the development process. Um, and that's for to measure it, to learn from it, to optimize the flow, and thus transform our process, our development process, and its results hopefully into predictable ones. So this is a taking in mind, having in mind that one of the things that most of projects um, have on their first days, and regardless of this nature, could be a waterfall project, agile, lean, I don't know. Each kind of projects, usually stakeholders start to ask this kind of questions. For example, how long does it take to deliver? And well, it depends. I don't have a crystal ball to see the future and to say, okay, we're going to deliver on this exactly moment. Another typical question is, when are we going to finish the project? And the same thing. I don't know. Maybe you have some roadmap, some planning, some Gantt, and you have some desirable due times, but it's not that that is going to happen exactly, right? And that's why also, instead of talking about projects, we want to talk more about products and how products evolve. And in that way, or in that sense, is that based on this flow metrics information that we have from our process, we can have some metrics that will help to answer some questions. For example, how long does it take to us to deliver value to our customers? That is a super simple metric, which is called lead time. And lead time is the time that occurs between a card leaving the backlog and reaching production. And on the other hand, a question like how much customer value are we delivering at any given time is another metric, super simple metric, which is throughput. And throughput is the number of cards or tasks or features delivered in a period of time. So based on this kind of metrics, flow metrics, is that I want to share with you some kind of information or types of information that you can start have in mind to make decisions based on metrics and have objective and objective data to make decisions. So I have a split into six types of information. The first one is monitoring and risk analysis, motivation and awareness, backlog analysis and prioritization, behavior analysis, projection, and basis for execution of experiments. So I will start to talk a little bit about each one of them. The first one is monitoring and risk analysis. So first of all, let me explain you this graph first. This graph shows how much time a card spends in each flow state. We take the flow through an issue tracking tool such as Jira, Rally, Trello, Shortcut, Pivotal tracking, among others. That's the source of our information, okay? Our issue tracker. The vertical axis shows the card's IDs, and the horizontal axis shows the number of working days. That's super important, working days. It doesn't has any holidays. It doesn't has any weekends, for example, to have a clear view related to when the team is working. So, for example, the card 6915 was 1 day in analysis, was 1 day in ready to go, 3 days in progress, 2 days in QA, and 3 days in review. If a color is not shown, as you can see in some of the bars for some of the cards or tasks, it is because the card spent less than one working day in that state. Okay, so let's see an example. Here we have this graph, and we can easily see that there are some strange behaviors. Um, for example, this first cards. Why did the cards located above here located above take so long to be delivered? We are talking about more than 100 working days, and the other one's not, right? So, yes, this is a super weird behavior in here, and the cards that later come down have much more normal behaviors, right? They have a little, have a life that does not exceed 5 days in general, except for some that reach up to 20 working days, but they're super smaller than the other ones in terms of their lead time. Okay, the time that they spent from backlog that when they left backlog till get or reach out production. But here is also something interesting. The cards ID on the vertical axis are ordered from smallest to largest. In general, issue trackers assign the cards IDs on a consecutively way, so we can then conclude that those cards, the ones that took a long time, are older because they have a smaller card IDs. Indeed, for this particular case, the team didn't know how to use the issue tracker well at first, and therefore they did not pass the cards from one state to another when it was appropriated. For example, and these unwanted behaviors were generated and otherwise unreal because the cards has already finished. In any case, there are still process things that the team had to work on. Make visible blockages due to dependencies, break the work in a smaller task and not in a single task, carry out the PR reviews as soon as the development finish, among others. And that is the kind of things that a team has to start asking themselves what is happening and how to improve themselves to make the flow um more, but first of all, real, but then more efficient. So the team is going to deliver value and deliver part of the product constantly on an efficient way. Um, then here we have another case. And what do you see that you think looks strange in this graphic, just in a first sight? Well, this one, right? We have just 1 day in development or in progress, and then we have a lot of days in QA. So why is the case of these cards? Why the QA process takes so much time? What happened, or what is happening? What is happening in case that the car has not been delivered? We can have these graphs for cards that are in progress and not yet delivered, for example. So, okay, that kind of things are related to monitoring and risk analysis because here you can see risks, what is happening along the development process, along the product, the delivery, or along team. Maybe team is demotivated. I don't know. Could be a bunch of things that could be happening. And monitoring to see if our flow is efficient, right? And if we are delivering on the right time, etc., etc. So then the second type of information is motivation and awareness. And here we have, for example, super simple graph that shows throughput for the throughput of tasks delivered, throughput of cards delivered or tasks delivered each week of a year. Okay, so why does throughput vary so much from week to week? Okay, here at the beginning was just okay, about around 8, 7 cards per week. Then it started to grow and now it's decreasing a little bit. Here, there is a lot of features, final features for our users, final users that were delivered. But in the later weeks, we don't have too much features and chores. A technical task has grown. And here in the last week, a lot of bugs were delivered. What is happening? Is our development process not being appropriated? For example, could be that we are not doing very well some technical things that are creating more bugs, or the specification of our tasks tasks is not the best. So we are creating and then delivering more bugs. Okay, so um, what things happen such that there are weeks that have been delivered many bugs instead of features, for example, and that kind of things are questions that you can ask yourselves to start wondering of what is happening and what could be done better and what can we do as a team. This is another example. This shows working versus waiting time. Working time is the time that effectively someone is working on a card or a task. For example, when you have your issue tracker, you have some columns like in development, in QA, in review, and that means that someone is working on that card, doing the development, doing the QA, doing the review. And that's the working time. And there are others that are waiting times or waste times, if we're talking more lean vocabulary, where are those states where cards are waiting to someone to take them. For example, ready for development, ready for review, ready for QA, ready for deploy are that kind of waiting stages. So here you can see for again each one of these cards, okay, the card IDs and days, working days. You can see how much time it was someone there was someone working on that task and how much time the card was waiting for someone to take it. So you can see here there is a lot of things that were waiting a lot of time, and the later ones were even much more efficient. The didn't have too much waiting time and was super little working time. And it talks about motivation and awareness because okay, again, to see how which things we can change, but motivation is because sometimes when we are working so hard on a task and we do not deliver that task, we get demotivated. Where is the work I have done? So if we are waiting too much to reach production, for example, that could be demotivate the team. And it's super important to have that kind of things in mind. And a final example in here is that again, maybe easily you can see here are some strange or weird behaviors. Um, so why, if we have cards that take too few days in development, for example, here 1 day, 1 day, 1 day, 2 days, 3 days, why would it take so long to review their PRs? Their see? Okay, so seeing the graph seems to be a behavior that we should discuss in the team to see how we improve our development process. Maybe we are not doing a correct in a correct way, the in a good way, the PR reviews, or maybe we are iterating too much because it was a lot of indefinitions when the card was developed, and now we are iterating between the review and the development, or maybe the ones who are doing the reviews are on vacation. I don't know. Maybe could be a lot of things. Could be a lot of things, and each team has their own context. So each team has to start asking themselves what is happening here. But usually a review thing or a PR review shouldn't take longer than the days that were developed. So these are super weird behaviors. Okay, and that kind of things also are for awareness but also for motivation of the team. Maybe the team doesn't know very well how to do PR reviews. I don't know, could be a lot of things. So that is the kind of things for this second type of information. And then the third one is backlog analysis and prioritization. And in this case, this is a new chart, a new graph I'm presenting here. This graph is called burnup. It shows in a cumulative way the delivery of cards by the team and the cumulative growth of the backlog. Okay, this is the delivery, the red curve, and the backlog is the blue one. So it is necessary that we are constantly monitoring the behavior of the delivery by the team versus the growth of the backlog. In this graph, we have two important insights. One, on the one hand, the delivery behavior of the team has decreased. Okay, it was like, ooh, super cool, and now it's a more flat curve. And on the other hand, the backlog has started to grow a lot. Both effects mean that it will take a very long time to the team to finish the delivery. And also, let's face it, the backlog always keeps growing. So if we look at it from the perspective of a project, it is capable that it will never finish. Okay, so, what to do? Well, on one hand, we have to see what happens with the constant growth of the backlog. Maybe we should do some review of the backlog, some backlog grooming, redefine which release each card belongs to, realign development expectations with stakeholders, remove cards, archive cards, I don't know. On the other hand, the delivery we has dropped, right? Right, and it's necessary to be clear about why, what has happened. If this burn up is built only on the basis of number of cards, for example, not points, but we can do it also with points. Um, could it be that the most current cards are bigger? So they take longer, for example. Um, could it be that it's vacation time and we have less development capacity in the team? Could it be that we have requirements of features to develop that are less defined and therefore iterate a lot before it can be delivered in production? Could it be that we have reached a point where our cards are simple, not well written or defined? It could be again a lot of things, a bunch of different things, and that will change depending on the context of the team again. Okay, so unfortunately there is no one size fits all answer for this because it depends. It always going to depend on the team's context and reality. And this is a second example in here. And in this case, cards are shown that haven't been finalized yet. Okay, so the red color in this case represents the time they have been in the backlog. So why do we have so many cards in backlog? For example, here till 40 working days. Maybe we should do some backlog grooming again and see if it still applies to have those cards in backlog. Maybe yes, maybe not. Maybe some have already been sold by other cards, and we must delete or archive them. Maybe it's okay to have them in there in the backlog. Okay, so that kind of things are also necessary to do constantly. Um, so now more about the four type of information are related to behavior analysis. And here I'm going to show you a new graph based on the lead time concept. Remember the lead time concept. Sorry. I told you at the beginning of this presentation that lead time is the time that occurs between a card leaving the backlog and reaching production. So this graph shows how lead time behaves. How many cards, vertical axis, have a specific lead time, horizontal axis. Okay. For high performing teams, we will love that most cards live for a short time. So it means that the lead time is small. Um, and okay, this is after the 4 first weeks of a team, and we don't have too many information or too much information. So we're not able to say anything at all at this point. But if we start tracking this behavior around the 5th week, 10th week, 15th week, and the 20th week, we can see that that there is some behavior. We can see that most of cars used to have little lead times, which is awesome. Okay, because that means that we are delivering value fast for our product. And well, also because it's similar to a beta distribution, but I can talk about it. It's more a statistical thing that we can talk on another presentation, for example, or another moment. So if over time we begin to see that we start to see that there are some peaks, some or some peaks or local maximums that um, we can have in mind to do some, for example, estimations. Okay, we can analyze it and improve our process, or maybe if we see that some local maximum starts to grow here, for example, in a very late moment, very big lead time, maybe we should do some improvements in our process and start to ask ourselves what is happening. Maybe we are creating too big tasks, and maybe we can break down them or split them into a more small cards that could bring value faster, reach out production, and bring value faster. So we can, I have already said that we can see that there are several local maximums in this aggregated curve. This the dot black one. Um, so we have here that we can see here there are several cards that are delivering 4 days, several then at 6 days, then at 8, then at 11, and then at 14 days. So this could be useful if the team estimates, for example. Maybe instead of estimating, we could do some t-shirt sizing using this info, saying, okay, a small card or a small t-shirt is 4 days, a medium t-shirt is 6 days, a large is 8 days, extra large 11 days, and extra large, I don't know, is 14 days, for example. Okay, and remember, is always working days. Okay. The fifth type of information is projection, and in this case, okay, I will show you again the burn-up graph again. But now we have two new curves, the green and yellow one. These ones, the green and yellow, are curves and projections based on Monte Carlo statistical simulations. Okay, based on the teams, which are based on the team's delivery behavior, the red curve, and the existing backlog, which is the blue curve. Um, so then the yellow and the green curves shows when we can, based on that information, when this backlog could be consumed, okay, delivered. Um, so now, first of all, we have a little kind of we have some problems in here because first of all, the backlog will probably continue to grow. Okay. Second, the behavior of the team may vary through a long time. And third, there is a little information of the delivery yet, and that's why the yellow and green curves do not even manage to intercept the blue curve on this graph. So this graph shows the burn up of a team that has been working on a project, yes, or product for a short time. But we know already that this backlog grew a lot from the beginning. This is the number of cards, almost 500 cards. That's more like sounds more like a traditional project more than a more lean project, for example. And this one is the same graph, but shows the burn-up of a team that is already ending the delivery of a product. The team was constantly, along time, reviewing, cleaning, and prioritizing the backlog. So when the backlog grew too much, we started to prioritize, realign the expectations, and the backlog were growing, but not in a super heavy way. So that made that the difference between the delivery, the red curve, and the backlog remain more or less constant, and there come a point where the backlog stopped growing. See, so that the end is near. We can see it. In addition, the delivery information is already fed up for the forecasting algorithm. So the yellow and green curves are almost the same. And that means that the uncertainty of finishing the backlog is simply within a small range of possible dates. These two different curves are based on different percentage of confidence. So the green one has a 50% of confidence, and the yellow one has a 70% of confidence. That's why, based on this simulation, they are quite different. But so, and regarding this, be careful. We cannot make the projections with 100% of confidence because otherwise it will be to have a crystal ball that predicts the future. No, reality does not work like that. We all only here we know that doesn't work in that way. So then we have the final type of information is that is the use flow metrics as a basis for execution of experiments. And why? What for? First of all, we can always run experiments in our teams to see how or what things fits better than other ones, or how behaviors are improving some things than other ones, and yada yada yada. So the idea is to maybe to evaluate the state before and after an experiment, and we can use it with data. And this is super objective data. And from that, start to see new ways of doing things and opportunities for improvement inside the team. So here's a real example. I didn't say at the beginning, but all the graphs shown in here are all real. We're all graphs that were from different kind of teams, um, different kind of products that we have been developing along years. Okay, so everything is real, and this example is also real. There was a hypothesis um, once upon a time where someone said, why have pairs of developers working on a single card? If each of us or of them, the developers, took a card, we will go twice as fast. Okay, instead of doing pair programming. So we start to do a lot of analysis. I will be very briefly here. I will show very briefly here just two little examples. But for example, this graph shows a person who in the first here in the first and in the third week was working alone, while the second and fourth week were doing pair programming with someone else. The average development time of the cards that the person working that week were in some cases shorter, and in other cases shorter when working alone than doing pair programming, but in other ones were longer. And the same happens when working in pairs. Okay, so it doesn't have it has any pattern to see here if how I do or deliver features a long time if I work in pairs or not. And here, the second scenario is for a person different from the previous one who always worked doing pair programming. But the same thing happens again. There is no pattern on the average time that a task takes. The tasks are different. Furthermore, there is no pattern that says if doing pairing takes you longer or not. So you cannot conclude that the initial hypothesis is true. Okay. Um, and well, I have already told you this is just limited, real, but not complete example because it was a lot of cases that we were analyzing. And in fact, we repeated this same analysis at the beginning of the team and the product development when they had already been working together for some months, and then almost at the end of this project or team to deliver a product. And we never, ever find any pattern at all. Never. There is no pattern that you can say. We would try to compare just little task with another ones, just bigger task with another ones, and we never found any pattern. So just ending, at the end of the day, if you can make decisions based on fact rather than forecast, you get results that are more predictable. Lean development is the art and discipline of basing commitments on facts rather than forecast. And this is a quote of Mary Pompendick on a paper that she wrote called Lean Development and the Predictability Paradox. So if you have the chance to take a look at it, I full recommend this paper. And just as a final recap, some important points. First of all, make decisions based on fact rather than forecast. Please, if you have facts, if you have data, it's much more better than saying like, I don't know, I think that this could work, or I think that we are not doing things right. So please, if you have data, use it. It's a super power tool. Almost all issue trackers has an API, so you can integrate to the API and extract the data to analyze it and see which behaviors or what behaviors are present and start doing that the analysis itself. Okay. Third, start with the simplest flow metrics such as throughput and lead time, as I have already told you. Continue then splitting the simplest flow metrics for different scenarios. For example, I don't know, just taking a look to macro. The macro throughput, but now I want to see for each team or for each kind of cards or tasks. I don't know, and are super simple lead time and throughput, and you can have a lot of info. Um, Show your team the metrics you obtain and all the interpretations, so you can together can make decisions to make improvements. Don't leave the decision just on one person, on the team leader, for example. Try to involve the team, and the team will gain more ownership also. And finally, train your stakeholders on the meaning of those metrics, behaviors, and analysis to get aligned for them to understand what are you doing, to understand the information that you're going to show them, for example, related to projections. And that will also calm down them regarding to when are we going to end the project and that kind of things. So please, again, have in mind all the data. You have a lot of information in there. Thank you all. Before you go, please take 1 minute to tell me how it went. I will share the link of the feedback form. And here is also my LinkedIn handle if you want to talk even more in the next days. Thank you.